In this video, we're going to look at one type of transformation of our basic graphs, and that's shifting. So if you haven't watched the video on the basic graphs, you'll want to go back and watch that one first, because then in this video and following videos, we're going to discuss all of the different types of transformations that we can do with those basic graphs, really with any graph, but we're going to focus on using those graphs from the first video. So when we talk about different types of transformations, in order to determine from the equation what type of transformation it is, we have to look at what operation is being introduced into the equation. So we'll know that we have a shift happening if we see addition or subtraction being introduced into the equation. So here f of x is our original, and then we're taking that original equation for f of x and introducing some addition or subtraction. Now the other thing we want to pay attention to is where is that addition or subtraction being introduced? So if it's being introduced inside of the original function, so it's with x, basically x is getting replaced with x minus a number or x plus a number. X is the horizontal direction, right? X is your horizontal axis when you graph. So any change that happens inside with x, that's a horizontal change. Anything that happens on the outside, not with x, that's going to affect the y direction. So that is a vertical change. So let's look at a couple examples. So here we have this function here. We want to graph this. We want to think of this as a transformation of one of our basic functions. And so first thing we have to decide is which basic function is it. If you look at the exponent there, it's a 2, right? So this is a transformation of y equals x squared. We're kind of thinking of this as, okay, if I start with y equals x squared, how do I take that and transform it to get this graph? So this is why in the basic functions video I said it's going to be helpful for you to have a visual of like what does that original graph look like. And of course you can always remind yourself by substituting in some x values and getting some points on the graph. There's no need to memorize anything here. Remember, we don't need to memorize what points were on this when we graphed it in the first video, because all we did was we plugged in some x values. So we can always do that again if we forget what it looks like. I would always say always plug in 0 and a positive number and a negative number, except for square root, because you can't use a negative value there. And so x squared is a parabola, opens up, vertex at the origin. Forgot to fill in my y values there. Okay, so we're seeing addition and subtraction here. The subtraction in here is happening with x inside the squaring. So that's our horizontal shift. Because x has been replaced with x minus 2. So that's a horizontal shift, and it's actually going to shift to the right 2 units. So the horizontal direction almost seems backwards to most of us. X minus a number shifts to the right, x plus a number shifts to the left. So this is why I think it's helpful to have a visual of what the original graph looks like, because now you can think about visually shifting each of those points to the right. So if I take the point, let's start with the vertex. If we take that vertex and we shift it to the right 2 units, so we're starting at the vertex, right 1 unit, right 2 units. Now it's going to be at an x value of 2. So our vertex, which was at 0, is going to end up at 2. And then we can do the same thing for the other points. So the point that was at -1 is going to move to the right 2 units as well. And same for the third point. Okay, now on the outside of the squaring, we have addition, so that's going to be a vertical shift since it's not with x. That's going to change the y direction, and it's going to move up 4 units. So the vertical direction kind of acts like most of us would expect. Plus a number is going to send it up, minus a number is going to send it down. So again, you can do this visually. That's the nice thing about shifting as opposed to some of our other types of transformations. You can take the vertex and visually shift it up. It's going to be at 4. And then the other 2 points, we're at a y value of 1. So if you move those up 4 units, they're going to be at 5. So then we can plot those points that we put in our table. The graph doesn't look the best because I'm a little squished, but you get the idea there. Okay, let's look at another example. So here we have absolute values in our function, so that tells us that we're doing a transformation of our absolute value function. Remember, this is the one that has a V shape. It shares some points in common with y equals x squared, particularly these 3. And so now we're seeing addition and subtraction again. X has been replaced with x plus 3 inside the absolute value. So that's going to be a horizontal shift. It's going to go to the left 3 units. So I'm a little cramped for space here, but visualize picking up each of those points and moving it to the left 3. So if you have more space on your paper, or if you have graph paper even, you can kind of just count with your finger, right? What happens if I move the point of the V to the left 3? It's going to be at negative 3. The point at negative 1 is going to be at negative 4, and the point at positive 1 is going to be at negative 2. And then outside the absolute value, we have subtraction, so that's going to be a vertical shift. So this is going to shift down 1 unit. And again, you can do that visually. The point at the origin is going to come down 1 unit. The other points are going to come down 1 unit as well. So that helps us figure out what the y column is going to look like. So here's our graph that's been shifted left 3 and down 1.